today's session we are going to see a new chapter, that is P block elements. Okay, so this chapter, it is a kind of inorganic chemistry. Okay, so already we have three types of chemistry: physical, inorganic and organic. Okay, right. So P block elements is a inorganic chemistry. Okay, so this chapter, from many recent type of questions the by board will ask you, and also complete the following type questions, and draw the structures of questions. So like that questions usually asked by board. Okay, so here we are going to see group 15 group 15 elements. Okay, already you have studied in group 13 and group 14 in your 11th standard, that is boron family and carbon family. Okay, so here we are going to see the physical properties or periodic trends of group 15th elements. First of all, you see, so what are the group 15th elements are present here? You see nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, so here the nitrogen N2, it represent it always in the dinitrogen, that is nitrogen exists in the form of N2. Okay, right. Phosphorus, arsenic and antimony and bismuth. Okay, its a configuration is related with helium, inert gas configurations, helium 2s2 2p3, phosphorus is a neon and 3s2 3p3, and arsenic 3d10 4s2 4p3, like that. Okay, so the general configurations are more or less the same, but here only difference is the principal quantum number is a different. No, for nitrogen it started with 2s2 and 2p3, and phosphorus it is started with 3 and 3p3, and like that arsenic and 4s and 5. Okay, so like that the configuration is the same, but it's the principal quantum number is different. Okay, so this is your the number, group 15th elements present. Okay, right. Here you see the nitrogen and phosphorus, it is a non-metals. Okay, and arsenic, it is a metalloids means 50% metal character as well as 50% non-metal characters. Okay, so antimony, it is a metalloid. Okay, and here this bismuth is a metal. Okay, arsenic and antimony is a metalloid, and bismuth is again the metal character. Okay, right. Here, so the overall trends, we observed that along the period and down the group, in your periodic table it represents down the group and along the periods. Okay, so down the group, these two characters are decreasing: ionization enthalpy and electronegativity. Okay, so and also down the group it decreases, but these are the characters are increases. What are the characters increases? Metallic character increases and melting point increases, atomic and ionic radii, these are the characters increases. Okay, right. The overall concept we summarized here: trend, reason. Okay, first of all, general electronic configurations. Usually the P block elements, the electronic configuration is, it represent ns2 np 1 to 6. Okay, so here the why it is called P block elements, no, because of the electrons entering into the p subshell. Okay, the p orbital, it has maximum number of electron present, that is 6. Okay, so ns2 np6, already you studied in your 11th standard, the boron family is ns2 np1 and carbon family ns2 np2. Here we have started with ns2 np3 because this is a nitrogen family. Okay, so nitrogen family, it is a ns2 np3, then oxygen, then halogen family, after that inert gas, group 18th family. Okay, right. Ionization enthalpy. First of all, students, what do you mean ionization enthalpy? Ionization enthalpy means the energy required to pick up one electron from the last shell or else the valence shell. Okay, right. That is called ionization enthalpy. Okay, right. Here ionization enthalpy completely decreasing, down the group completely decreasing, so that only the metallic character increases. Okay, okay. Here why it is completely decreasing? Atomic number increases, number of shells also increases, the distance from the nucleus and the nucleus and the outermost electron also, the far distance, so ionization enthalpy completely decreasing. So you see that the down the group, the first shell it is a shell nucleus and the outer cell, and after that then it is bigger size, then bigger, smaller. Okay, this is the distance is small because of nucleus and outermost electron. Between these two the distance is small. Here the number of shells increases because of atomic number increases, the number of cells also increases. Atomic number increases, number of cells also increases. So number of cells increases. Here what happened? Here the distance between the nucleus and the outer shell electron is far away from the nucleus. Okay, so here completely the removal is very easy. So ionization enthalpy is completely decreasing. Okay, here we cannot picked up one electron from the last shell because of this. Here the nucleus and the electron is nearer to the nucleus. The electron present in the it is nearer to the nucleus, so we cannot pick up easily. But here it is far away, so completely the ionization enthalpy decreasing. Okay, right. So electronegativity. Next is electronegativity. Electronegativity means the tendency to share that to attract the share pair of electron towards itself, or the pulling capacity. Okay, so that is called electronegativity. Electronegativity also down the group completely decreasing, along the period it will increases, because so that only the fluorine is a highly electronegative element. Okay, here the reason is why down the group it completely decreasing, atomic number increases, atomic radii also increases. So the same concept, distance between the nucleus and the electron is far away, so highly in the the attraction is less. Okay, the pulling capacity is less. Okay, because of some the inert the pair, some the d orbital and the effective nuclear charge is very less. Okay, for down the group. At the same time, along the period the added electron is less, so the effective nuclear charge is very high, because all the electrons present in the outer shell is very nearer to the nucleus. So இது நியூக்ளியஸ் கிட்டேயே இருக்கிறதுனால the added electron வந்து 1 or 2 electrons தான் ஆட் ஆகும் எதில் along the period. அதனால வந்து என்ன செய்யும் அப்படின்னா இது வந்து highly effective nuclear charge இருக்கிறதுனால ஈஸியாக அந்த அயனைசேஷன் என்தால்பி வந்து ஹையாக இருக்கும், டவுன் த குரூப் வந்து எப்படி இருக்கும், லெஸ்ஸாக இருக்கும். அதே தான் எலக்ட்ரோநெகட்டிவிட்டியும் சேம் கான்செப்ட் தான், டவுன் த குரூப் வந்து லெஸ்ஸாக இருக்கும், அலாங் த பீரியட் வந்து எப்படி இருக்கும், ஹையாக இருக்கும், பிகாஸ் ஆஃப் த ஹைலி எஃபெக்டிவ் நியூக்ளியர் சார்ஜ், பிகாஸ் ஆஃப் த நியூக்ளியஸ் அண்ட் த எலக்ட்ரான் இஸ் நியரர் டு தட். ஓகே, ரைட். ஸோ this is for your electronegativity for down the group decreases and along the period increases. Okay, right. Next one, metallic character. Metallic character also down the group ionization enthalpy decreasing, at the same time the metallic character would be increases. Okay, right. So here the atomic number increases, atomic size in the metallic character automatically increases. Okay, along the period the non-metallic character increases, so that only the halogen family and the remaining the oxygen family, many elements are exist in the form of non-metallic character. Okay, so melting point you see nitrogen is a minimum melting point. At the same time arsenic is a maximum melting point. So melting point increases nitrogen from oxygen, arsenic, but again then it is decreases antimony to bismuth. Okay, right. After that the atomic radii and ionic radii along the down the group it increases, both atomic number increases, number of shells also increases, so atomic radii and ionic radii also increases. For along the period it completely decreases, the same concept due to the highly negative, highly effective nuclear charge. Okay students, you should know that down the group வந்து ஷெல்லோட இது வந்து இன்க்ரீஸ் ஆகிட்டே போகிறதுனால என்ன செய்யுது, அயனைசேஷன் என்தால்பி எலக்ட்ரோநெகட்டிவிட்டி எல்லாம் கம்ப்ளீட்டாக என்ன செய்யுது, டிக்ரீஸ் ஆகுது. ஆனால் அலாங் த பீரியட் இது இன்க்ரீஸ் ஆகுது. ஏன் அப்படின்னா இங்கே வந்து ஆடட் எலக்ட்ரான் வந்து அதிகம் டவுன் த குரூப்பு. அதே இது அலாங் த பீரியடில் வந்து ஆடட் எலக்ட்ரான் வந்து 1 or 2 எலக்ட்ரான்ஸ் ஒன்லி இட் என்டர் இன் டு த லாஸ்ட் ஷப்செல். ஸோ அங்கே என்ன நடக்குது அப்படின்னா இந்த நியூக்ளியஸ்க்கும் எலக்ட்ரானுக்குள்ள டிஸ்டன்ஸ் வந்து கம்மியாக இருக்கிறதுனால எஃபெக்டிவ் நியூக்ளியர் சார்ஜ் வந்து ஹையாக இருக்கும். எப்போவுமே இந்த நியூக்ளியஸ் வந்து எலக்ட்ரானை அட்ராக்ட் பண்ணிகிட்டே இருக்கும். ஸோ அதோட எனர்ஜி வந்து ஹையாக இருக்கும். நம்ம we cannot pick up one electron from the last shell, we cannot remove easily, but here no, it is a far distance, we can easily remove, so that these two characters are decreasing down the group, but along the period two characters are increasing. Okay, so this is overall periodic trends for group 15th elements. Students, you see one question. For this group, nitrogen is a unique properties compared to other elements present in this group. Because of this nitrogen is these 2 points. One is smaller atomic size and highly electronegativity, and the third one is the p pi bond. Here p pi bond because of vacant d orbitals. Okay, one question: why for group 15 nitrogen acts as an anomalous in nature, that is unique property. Okay, special character presence of compared to other elements present in this group. Okay, here the reason is small size, high electronegativity and vacant d orbitals. Okay, so because it's a nitrogen, the size would be very small, and the electronegativity, according to electronegativity, the number range, nitrogen is more electronegative compared to other groups like oxygen and fluorine like. Okay, right. Here the vacant d orbitals, only s orbital and p orbitals are present, not extend for d orbitals. Okay, this is a reason, this is a unique property when compared to other elements present in this group. Okay, so according to Lewis base concept, the nitrogen is triple bond and the lone pair of electron is present because it exists in diatomic form, no, N2. Okay, so this presence of this availability of lone pair of electrons, it undergoes to form p pi bond orbital overlapping. Okay, so the presence of other elements, it cannot undergoes p pi bond orbital overlapping. It is a anomalous in character. Okay, and after and also the bond enthalpy also very high because of the presence of triple bond. You see this phosphorus single bond phosphorus, arsenic single bond arsenic. So this single bond easily we can break up. The energy needed to requirement is very simple, but here the presence of triple bond we cannot break up easily. Okay, so these are the characters. It is act as a anomalous in nature. Okay, or else unique property. Okay, so here the group 15 elements easily react with hydrogens to form hydrides. Okay, so for nitrogen react with ammonia NH3, PH3 and AS hydrides. These are the hydrides. Okay, so here this is a less basic character. okay, less basic character. So it is the reducing character increases. Bismuth is a strong reducing character compared to this ammonia. But in the stability means because of the hydrogen bond present, this in the stability order அப்படின்னு சொல்லி பார்த்தோம்னா NH3 is a more stable compared to bismuth BiH3. ஏன் அப்படின்னா இந்த ஹைட்ரஜன் இந்த நைட்ரஜனோட பாண்டா இருக்கிறது வந்து it is a smaller size, so it holded with very strongly, we cannot break up easily for this ammonia molecule. ஆனால் இதில் வந்து பார்த்தோம் அப்படின்னா it is a larger size, so the bond length also larger, so easily we can break this bond bismuth H3. okay, the bismuth hydride வந்து ஈஸியாக break up பண்ண முடியும். ஆனால் NH3 வந்து we cannot break up easily, we can't break up because of it is according to stability it is more, it is a less. okay, but the reducing character, which means that is a basic character, it is a less, it is a more. okay, right. And also reactivity towards oxygen. So this the 15th group react with oxygen to form trioxides and pentoxides. Higher the number of oxidation state, higher would be the more acidic property. This is one mark question. okay, right. So on the order also I will give you for the question format. And reactivity towards halogens, so the group 15 elements are react with halogens to form trihalides and pentahalides, like for PCl3 and PCl5, like that the halogens it produced. okay, and metals, the group 15 elements are reacted with metals also, it react to form metal carbides. okay, that's all children for physical properties. okay.